In this video, I am going to show you how to make 12 channels transmitter by using this tiny chip. How it's possible? Because this chip has only 6 GPIO pins and one of them is a weak input-output. So let's find out how we do it. First of all, I am going to assemble my transmitter circuit. Here is the schematic. For my convenience, I made homemade PCB for this project. And start soldering from ATtiny chip. For jumper connectors, I use insulated copper wire. I use 315 MHz transmitter module. You can also use 433 MHz transmitter module. This temporary connector is soldered to program the chip. Now I open the Arduino IDE and start a new sketch. Initially I define my TX pin. I use PB4. Then I assign 2 bytes variable for holding the button values. In the setup function, I define TX pin as output and assign digital low to TX pin. Assign 0 to the previously defined keysum variable. Since I'm using ATtiny 13A, I only have 1K programming space. So I have to use my own encoding method to minimize the memory consumption instead of using pre-written libraries. My method like this: it has start pulse, then 12 bits for identification, another 12 bits for data, finally stop pulse. The start pulse is 5 millisecond long high pulse and 500 microsecond long low pulse. The stop pulse would be 3 millisecond long high pulse only. Data 1 pulse represented by 1 millisecond long high pulse, then 500 microsecond long low pulse, as well as data 0 represented by 500 microsecond long high pulse, 500 microsecond long low pulse. Then back into the code again. This is the function for start pulse. And the stop pulse function like this. This function for data 1 pulse, and this one for data 0 pulse. After I wrote the functions for pulses, now I am writing message sending function. I define 4 bytes variables as tx msg to hold the transmitting data, as well as 2 bytes variable for tx id. Since my tx id is 12 bits long, the range is 0 to 4095 and I am choosing 3500. Now we put txid into txmsg variable, then left shifted it by 12 bits. Now I inserted keysum value into txmsg variable. Then I call start pulse function. This for loop will transmit the 24 bits in the txmsg variable. After that it calls stop pulse function. This is the key scan function. It basically consists of 4 major parts. As you can see in our schematic, we utilize port B0 to port B3 for our key mesh. In this each part, we put one of a pin as output, read the rest of 3 pins. If one of the key is press detected, it will set the corresponding bits in the keysum variable. In our main loop, we call key scan function, and if it detected key press, then it will send the corresponding message. Now we compile this code. I am simulating this code before I program in the actual chip. Since everything is okay, I am going to program the actual chip. For this I am using USB ASP programmer, and I made small modification for this programmer for my convenience. After upload this code, I remove this temporary connector. Now our transmitter circuit is completed. In this version, the transmitter works only one channel at a time. And I hope to upgrade the code for multiple channel at a time in a future video. If you have any suggestion on this video, please leave a comment, and those who have still not subscribed my channel and wish to watch the videos like this, please hit the subscribe button, and we will meet again in our receiver circuit video.